In this video, we're going to talk about audio processing. Audio processing means that we're taking a recorded or some sort of audio signal that's coming through, and we're doing something to it. We're applying some sort of process for various reasons. We might want to clean the audio a little bit. Maybe it's coming in distorted or there's some other noise, and we want to clean it up a little bit. Maybe we want it to sound bigger, or we want it to be softer. We want it to sound like it's coming from a particular space. There's all sorts of things that we can do to process our audio, and different reasons why we might apply one sort of process over another, or different reasons why we might do it. One might be for, again, cleaning up, others for aesthetic purposes. So this video is going to go through a couple of those different processes that we use frequently. Gating is a form of dynamic range processing. Okay, so dynamic range is an important keyword to remember. It's the difference between the loudest and softest parts of an audio signal. What gating allows us to do is say, unless our audio signal passes a certain threshold, like an imaginary line, think, then we're not going to allow the gate to open and allow that audio to pass through. It must not be something that we want, right? So let's just say that we're recording our voice and there happens to be some chatter from some other people far away from us or something like that. It's not going to be very loud. So as long as we set our threshold at a particular level, if I'm not speaking and all the microphone is picking up is the people way behind me talking for a little bit, the threshold will not be passed and the gate will not be open. We will block out that incoming sound, and the result will be silence. We do this a lot of times with, say, electric guitars. That's another good example. You've got an electric guitar with an amplifier, and there's lots of fuzzy, crackly sound, even when the guitarist isn't playing. Well, we want the gate to close on that noise in between when the guitarist actually starts strumming and playing, right? At that point, the audio signal will pass the threshold, the gate will open, and will allow that signal to pass through. Another way that gating can be useful is if maybe you have a long recording, like an audiobook or something, and then you want to use a gate to effectively edit out all the breath noises from the voiceover talent reading through this audiobook, right? So instead of editing each individual thing, you can use a gate to help just block out those sounds and sort of be automatic volume control for those unwanted sounds. Next up is another form of dynamic range processing called compression. Super important. A lot of things that we do with audio comes from compression. So what compression will do, like what you're seeing here, the image is a audio waveform, and it's basically cutting a line through some of the peaks there. A lot of people like to think of compression as automatic volume control. Think about it like this. Again, we're going to set a threshold, some sort of imaginary line that represents volume. And anytime our audio level exceeds that threshold, it's going to start pushing that audio signal back down to tame it a little bit, right? Compress it down. So the initial reaction of using a compressor is actually going to be a quieter sound. But overall, we are just reducing the loudest parts of the sound closer in relation to the quiet parts of a sound. That's why it's called dynamic range compression. We're compressing out that dynamic range. Now, that can be important. A lot of people also associate, well, compression is going to make my sound a lot bigger, more substantial. And yeah, that's true a lot of the time. That's what it's used for. But the initial reaction is going to be to compress down the loud sounds, and overall, things are going to sound quieter. But then what we do is we add makeup gain, and now we have this quiet part in much closer relation to the loud part, and we raise makeup gain, and then we have a more consistently loud piece of audio overall. So compression is an important tool for dynamic range processing. Equalization is the main tool that we use to process frequency. So frequency range of human hearing is 20 hertz to 20,000 hertz or 20 kilohertz. An equalizer allows us to view that frequency range and treat it as almost like frequency-specific volume control. I can make boosts and I can make cuts based on very specific areas of that frequency range. Easiest way to think about it is your car stereo is divided into bass, mid, and treble. That would be 3 different areas of that 20 to 20 kilohertz frequency range, and you can raise or lower the intensity of audio in those particular areas. So different kinds of equalizers, like a graphic or a parametric equalizer, will give us particular and specific control over or different frequency ranges, also called frequency bands. So that's equalization. Also on our list of audio processing is reverb. Here's a picture of famous Abbey Road's reverb chamber, where we're actually creating a physical space that lets sound bounce around the acoustics, like the walls and the columns and all that, to create a different sort of texture for our sound. And in this old school application of it, they're actually putting microphones in the reverb chamber, creating a sound, and then recording how the room reacts. Now that's a very old school way to do things, but also the most authentic. We can use computerized and digital versions of reverb that sort of simulate an acoustic space to which our sound will be perceived like it's coming from. For example, even though we're recording in a controlled space, like a recording studio with a nice microphone, we can then apply reverb after the fact to make that sound like it's actually echoing from across the hall of a big church or something like that, to add some echo and some slapback delay, and to make it sound like that particular recorded audio is actually bouncing off this sort of virtual acoustic space. It can also be very useful to make things like creatively, to say make a voiceover sound like it's being thought instead of being said, or that it's a dream sequence in a film or something like that. That's how it's used creatively. Finally here, we've got some pitch correction. So it's sort of become a audio processing tool all to itself, right? And we know it best as like the T-Pain effect or something like that, where you can very clearly hear this unique sort of sound. And really what's happening is a computer is identifying particular pitches that want to be included in a song, like the key of C sharp major, right, in a song or something like that. And the recorded audio will then be pulled in one way, in one direction or the other, towards the pitches that fit that particular musical scale. And if you are familiar with something like the T-Pain effect, basically what happens is during that process, they turn up the retuning speed to pull from the actual recorded pitch to, maybe the one that is wanted, that was asked for, and it'll pull them there really fast, and you get that sort of robotic sound. And that can be useful for other applications as well, to make a voice sound just deeper and more intense, maybe for like monster sounds and things like that. All sorts of reasons why we might want to use pitch correction. Last thing on my list is noise reduction. And what you're looking at on the screen here is a picture of a spectrogram. Now, what this is showing us is on the x-axis, from left to right, we're looking at time. And then then we're looking at frequency range on the y-axis, right? So 20 hertz on the bottom, low frequency sound, and 20 kilohertz on top, the high frequency sound. And then the brightness of the image is the intensity of those frequencies at that moment in time. Now, this is a particularly silly picture where there's like a face in there, and this is just sort of like an audio joke, basically creating music that contains the intensity of certain frequencies to make an image on this spectrogram, right? And so that's sort of a silly application of it, but it's useful in taking away unwanted sounds from recorded audio. I can maybe pinpoint some very particular frequencies that are distracting or get in the way of the things that I actually want to be included in my audio, and I can very specifically pinpoint them and then get rid of them. All of these different tools, along with many, many more, can be used to, again, clean up your audio, make it sound its best, increase the sound, reduce the dynamic range, we can change the pitch, we can clean up noise. All that is made possible by audio processing.